Welcome to Modern Dev episode 3, and today I'm going to show you how you can use Java streams to use filter, map and reduce operations. So the concept of filter, map and reduce originates from functional programming, and it's in this form available since the introduction of Java streams. So let's go right into it. Let's assume we have a list of some numbers. And if we call the stream method on this now, this is the stream API, which now gives us the possibility to call, for example, map, besides other variations of it, filter, and reduce. So the stream API has many other functions, but filter, map, and reduce are the ones, if you combine them, you can solve, I would say, 99% of all your common problems that you have to solve usually. And the rest of the API, you could say there's a lot of like specialized versions of these three. So what does filter do? So filter, so you specify a predicate with filter, which defines basically the elements you want to keep. And so if you have a list with integers, then after you do filter on a list of integers, you get a list of integers, but depends on how many elements your filter took away. You could get the same list because your filter didn't do anything. You could get less elements, or you could get 0 elements because your filter took away everything elements. All the elements. So with map, it's like if you have a list of integers, let's say 10, and you do a map operation, you get back a list with also 10 elements. So the length of the list stays, but the element itself changes because map operation changes every element of your list, and that what happens is basically what you define your map operation. And so finally, reduce is an operation that combines all your values of your list into a single value. For example, you could sum up all the elements of your list. For example, if you have numbers. So let's see how that works. So we start with filter. So we define a predicate that basically is responsible for declaring what elements we want to have and which ones we don't want to have. So let's say E for element is supposed to be an equal number. That means E modulo 2 equals 0. That means it is an equal number. So that we see something here, I do a collect operation in order to get back a new list. Collectors to list. So and as you can see here, now we only get the list of 2, 4, and 6 because these are the even numbers. So I replace the filter now with a map call to demonstrate how map works. So we again say E, could name it any other way. Let's say we just multiply E by 2, which means instead of 2, 3, 4, 5, 6, we get back 4, 6, 8, 10, 12 because we multiplied every element by 2. So if we do a reduce, we don't need to do a collect because we already get a single element. So in reduce basically gets a lambda, or needs a lambda with 2 arguments, because reduce always works in pairs. So in the first iteration it would call do your reduce on the first two elements, and then the result of this will be combined with the third element, and the result of this will be combined with the fourth element, and so on until you're done. So here you just say, basically specify what's done with your pair. So we just say A plus B. And now we get an optional 20 because, so if you do the calculation, 2 plus 3 is 5, plus 4 is 9, plus 5 is 14, plus 6 is 20. So you get an optional with 20 because, so you get the optional because in case, for example, if you would have a filter operation before that would remove all the elements, then you would have an empty list and your reduce would have nothing to do because there are no elements left. In that case, you would get back an empty optional. So that is why the reduce returns you an optional, because there are cases where there's basically no value that can be returned. So let's combine all of these steps. So we first do a filter, we do the same thing as above. We say just give me all even numbers. Now from what's left, map each number and multiply it by 2. And now reduce it and just calculate everything together. And then we have a 24. Because basically we get back 246 multiplied by 2. That would give us 4, 8, and 12. 4, 8, and 12 is 24. That's why we get 24 here. So let's do one final example to demonstrate you an empty optional. Let's say E equals -1. There is no element -1, which means our filter removes everything from the list, and now we get an empty optional. So that's basically it. Thank you for watching. Subscribe to the channel. Please leave me a comment if you have any questions or if I missed something here. And definitely write me a comment and tell me what you want to see next time, that I can organize the upcoming episodes. Thank you very much. See you next time. Goodbye.